Hey everyone, Ms. B here. Let's do the Geometry Chapter 1 summary for your review. So we focused on three main ideas in this chapter, and the first big idea was just describing all different types of geometric figures. So you should be an expert at naming points, lines, planes, segments, and then also don't forget about the length of a segment, or the distance between 2 points, is just written as the two endpoints with no bar on it. Also how to name a ray, and how to name angles. One thing that we are not covering just yet is classifying polygons, so we will be talking about that at a later time. Our second big idea is about measuring geometric figures. So we use rulers and protractors to measure different geometric figures, but if we're looking at a coordinate plane and we have points, we could calculate the distance between those points using the distance formula. We could also calculate the middle or the midpoint of a segment using the midpoint formula. Another idea here was classifying different angles, and we discussed complementary angles are simply angles that would add up to 90 degrees. Supplementary angles are angles that would add up to 180 degrees. Don't forget how to classify angles as acute, which is any angle between 0 and 90 degrees. Obtuse, which is any angle between 90 and 180 degrees. Right, which is an angle that measures exactly 90 degrees. And straight, which is an angle that measures exactly 180 degrees. For this first example, let's just plot a couple points here and determine the midpoint and the distance. So given the following points, E at 1, 4, and F at 3, 2, we would go over 1 up 4 for point E, because remember, the first number in a coordinate is how you move left or right, or how you move along the x-axis, and the second number in the coordinate is how you move up and down or along the y-axis. So to plot point F, I'm going to go over 3 units and up 2 units. So that will bring me right here, and I'm going to call that F. Let's connect these, and we're looking at segment EF. Now the first thing I want to do is determine the midpoint. If I want to determine the midpoint, I can hopefully identify roughly where it should be, but I also need to calculate the exact coordinate where it is. So that yellow dot is where I think it roughly should be, the middle between E and F. But we have a wonderful formula to help us find the exact middle between those points. And that midpoint formula is simply finding the average between the x's and the y's. So we'll start by finding the average of the x's. Just add up the x coordinates and divide by 2. And that would give us 4 divided by 2, or 2. Now let's do the same thing for the y's. Let's add the y coordinates, 4 and 2. And then we'll divide that by 2 to get the average. And the average is 6 divided by 2, or 3. So let me graph that point over 2 units, up 3 units, and lo and behold, eureka! I have landed on my yellow dot right in the middle, and that should be the exact midpoint. So I'm going to plot that there and just label it M, so we know that is the middle between E and F. And the next task is to just figure out what is the distance. So what is that length from E to F? Well, I cannot count the number of units because it's on a diagonal, so that would be inaccurate. Whereas if I had points on my number line like this, we could easily figure out the distance by counting the number of units. In this case, I cannot. So the distance from point E to point F I can denote as the length of segment EF, or just EF with no bar on top. And the distance formula tells me I can take the square root of the difference of the x's, so the x's would be 3 minus 1 squared, plus, now let's do the same thing with the y's. Let's take the difference of the y's, 2 minus 4, and then don't forget to square that quantity. Now let's just use order of operations to clean this up and simplify. I end up with, don't forget the square root all over again, or your final answer will be wrong. 3 minus 1 is 2 squared, plus 2 minus 4 is negative 2 squared. I get 4, and then again 4. 4 plus 4 gives me 8. So that means the distance between E and F is not 8, it's the square root of 8. And if we were to type that into our calculator to get the approximation, the square root of 8 is just roughly 2.8 units. So that's the length of that segment. That seems pretty accurate to me. So the distance between E and F, or the length of segment EF, is 2.8. Just to recap, complementary, supplementary, and then vertical angles, let's just sketch out the couple differences there. If I'm talking about complementary angles, I'm just simply talking about two angles that add up to 90 degrees. So if I had an angle here that was, let's say, 40 degrees, and then another angle that was 50 degrees, those two angles together would be complementary. Typically, that also would look like a right angle divided up into two other angles. So there's another example of two complementary angles. So angle 1 is complementary to angle 2 in this picture. Okay, remember, supplementary angles are angles that would add up to 180 degrees. So let's say we have this obtuse angle here, and it's 100 degrees in measure, and then we have another angle that measures about 80 degrees. If we put those two together, their sum is 180, and therefore they are supplementary. Typically, we see these as a linear pair or forming a straight angle. So there's two angles put together, angle 3 and angle 4, that are forming a straight angle or a linear pair. So we would say angle 3 is supplementary to angle 4. Lastly, vertical angles are angles that are non-adjacent and they're directly opposite one another, and we would say that those are equal. So in this scenario, in the picture that I drew, we can say that angle AOB is vertical to angle COD, and in fact those two angles are congruent. The last big idea is understanding equality and congruence, and just those two things mean the same. If segment lengths have equal measure, then we say that those segment pieces are congruent. Now don't forget, if you have a segment and then there's a segment bisector, that just simply means it is intersecting at the midpoint and makes the two remaining segments congruent. Same thing with an angle. If we have an angle with an angle bisector, that just means that it is splitting up that bigger angle into two congruent angles. A quick example with angle bisectors, we're given that ray VZ bisects angle UVW, and the measure of angle UVZ is 81 degrees. We want to find the measure of angle UVW and classify it by its measure. Whenever you're given a word problem like this, the first thing to do is draw the picture. So we have some angle UVW. So let's just sketch that angle just generically and label it UVW. And we know that we have a ray VZ, so VZ, bisecting that angle. So you should mark the angle with two congruent angles since we know that this is a bisector. Let's label angle UVZ 81 degrees. That makes angle ZVW 81 degrees. And therefore the measure of the whole angle UVW is simply 81 plus 81 by the angle addition postulate, and so we get 162 degrees. When it says to classify the angle, we're going to say, is it acute, obtuse, right, or straight? and this is an obtuse angle. So my picture was not exactly accurate, but you had all the information filled in correctly and you answered the question appropriately. Last but not least, don't forget how to use our fun measuring tools, such as a ruler to measure segment lengths, and a protractor to measure angle measures. And if you're having any difficulty using these tools, please come see me for a demonstration on your own time. Alright, that brings us to the end of our video. I hope you learned something about the essentials of geometry and you can show me what you know on the Chapter 1 test.